Which letter comes first in alphabetical order, S or M? A vast majority of you likely determine the answer by singing the ABCs in your head. So how is this relating to computing? If we wanted to store the alphabet in a data structure in our code, we would likely use an array. Arrays are great because they store items in a list, and each item is associated with a number, often called an index. But what if we wanted to create a list where there was no indices? Instead, each element in the list is accessed through the element that comes before it. In the ABC example, the position of one letter relative to another can be found by using the letters before it. For instance, we get to D by going through C, and we get to C by going through B. This is how linked lists work. At a glance, this complex business about accessing elements through previous elements instead of simply storing elements in order sounds completely useless, but the benefit comes in when we consider memory. Linked lists are particularly useful when dynamically allocating memory. Memory allocation is just when you make space for something in memory so you can store it, and dynamic just means it's changing. This means we should use linked lists when a list needs to be created while the program is running, because we don't always know if we're going to have enough continuous space for the list. When allocating memory for an array, a specific space is scoped out so all the elements in the array come in one after the other. In this system, if we wanted to access, say, the fourth element, we can just go to the value stored in the memory address 4 up from the starting element. But if we wanted to make our array longer, then we might potentially need more space because all the elements have to be in order, and the space we scoped out originally may only have enough room for the original array. This is not a problem for linked lists because linked lists use nodes that contain each element, and they do not have to be in a specific order. This makes modifying the size as easy as finding a new space in memory that only has to be big enough to store one node, or, if you are removing a node, just letting garbage collection eat up that space in memory so something else can use it. This is similar to how your brain stores the alphabet. When you were learning the letters of the alphabet, you were acting in the human version of runtime, meaning your brain had no idea whether this group of elements would be added upon or reduced, so it stored it in the human equivalent of linked lists. The ABC song serves as a mnemonic device that is a great way of connecting all of this data by letting you access each element in a way that is efficient for how you stored it, which is exactly what computers do. Ultimately, linked lists are useful for dynamic memory because unlike arrays, linked lists do not require continuous memory space, allowing for efficient allocation and modification of elements during program execution. I'm Brandon. Thank you for watching. Remember to like and subscribe.